So now, again, let's do the further math, core 2. Oh, sorry, why it doesn't work? Core 2, chapter 3, which is calculus, method in calculus. So number 1, substitute u becomes e to the power of x, find, okay. So now when u is e to the power of x, du over dx becomes e to the power of x. So integral 1 over u plus 1 over u times dx becomes du over e to the power of x, which is u. So u du. So integral u squared plus 1 du. So u squared plus 1 is arctan. So now we know this is arctan. So here arctan of u plus c, but u is e to the power of x plus c. So this is the one. So number B. This is the improper the integration. So limit b becomes negative infinite. So integral b to 0, let's say 1 over e to the x plus e to the negative of x dx plus limit a becomes infinite, 0 to a, e to the power of x, e to the power of negative x dx. So b negative infinite arctan ex b 0 to b plus limit a becomes infinite arctan e to the power of x a to 0. So limit b negative infinite arctan 1 minus arctan e to the power of b plus limit a goes to infinite arctan e to the power of a minus arctan 1. So let's see. E to the power of x graph looks like this. So when it goes to negative infinity, it goes to 0. So here arctan 1 becomes pi over 4 minus arctan 0, which is 0, plus arctan infinite. When it goes to infinite, it is power over 2 because arctan look like this. So when it has the negative infinite input, it approaches to, not approaches, but it goes to the horizontal asymptote, which is pi over 2 minus pi over 1. 4, sorry. So pi over 4, so the answer is pi over 2. So number 2, mean value. Let's select some questions. So number 3, number 2, yeah, maybe number 2 is more, looks serious. So delete. Okay, number 2, 1 plus 1 minus cos x over sine squared of x, the mean value. So here b minus a integral a to b f of x dx. So this is the mean value of the function. So b minus a pi over 3 minus pi over 6 integral pi over 6 pi over 3 and 1 minus cos x over sine squared of x sine squared of x dx. So this one 6 over 2, so pi over 6, so 6 over pi over 6 pi over 3 So 1 over sine square root of x is cosecant square root of x minus cosine over sine x is cotangent of x and cosecant of x. So we know those whose derivative becomes negative secant square root of x. This one negative cotangent of x minus negative cotangent of x, cosecant of x is the derivative of cosecant of x. So this becomes cosecant of x. So 3 over pi, 6 over pi, 6 over pi. So negative cotangent of pi over 3, square root of 3, plus cosecant 2 over square root of 3, minus pi over 6. So this one is 1 over square root of 3. So pi over 6 is square root of 3 plus 2. So 6 over pi. The first one is 1 over square root of 3, means 3 square root of 3 over 3. Right? 1 over square root of 3. Okay. And plus square root of 3 minus 2. So 6 over pi, 4 square root of 3 over 3 minus 2. Please check the answer. Anyway, something like this. So let's go for the number 4. Arc cosine x squared. So now let's derivative of that. So this is chain rule. We know arc cos x, the derivative. So let's arc cos u. So 1 over square root negative, 1 minus x squared, which is x to the power of 4, times 2x. So this is negative 2x over 1 minus x to the power of 4. This is arc cos x squared derivative. B, hence or otherwise calculate. Okay. So now let's find something similar form. So this one, now we have 1, but it has 16. So let's change it some form, like 16, 1 minus x over 16 to the power of 4, and 3x dx. So now let's set x over 2 becomes u, du over dx becomes 1 over 2, dx is 2 du. So integral, so 3x is 2u, and 4 square root 1 minus u to the power of 4, and 2 du. So we need the negative, and it's almost there. So 3 over 2, integral negative 2u, square root 1 minus u to the power of 4 du. So negative 3 over 2. Now we can use the result of the A. So this is arc cosine u squared plus c. So negative 3 over 2, arc cosine u was x over 2. So x squared over 4 plus c. So this was the answer. And number 5. So let's do that. Arctan is this one, and let's make it. Find the derivative. So arctan's derivative is 1 over 1 plus x squared. So let's use the chain rule. So f prime of x, 1 over 1 plus 2x plus 3 over x minus 1 squared times, and quotient rule. So 2x minus 1 plus, minus 2x plus 3 and 1. and x minus 1 squared. So I will multiply this x minus 1 squared on the left side. So here x minus 1 squared plus 2x plus 3 squared. And 2x minus 2 minus 2x minus 3. So negative 2x minus 3. So we have negative 5. Here x squared minus 2x plus 1, 4x squared, 12x plus 9, 5x squared plus 10x plus 10. Oh, that's why. Negative 1 over x squared plus 2x plus 2. And b, f prime of x is like this. So now let's start from the denominator. So x squared plus 2x plus 2 is x plus 1 squared plus 1. So this one is larger than x plus 1. X plus 1 squared plus 1 is larger than or equal to 1. Because we know this is negative 1 comma 1 and opens up like this. So like this. But we need to find the reciprocal of that. So x plus 1 squared plus 1 over 1 becomes when the number is reciprocal, the inequality symbol will be the opposite side. So 1, but it never be negative, so larger than 0. And actually this is f prime of x. Modulus of f prime of x becomes smaller than or equal to 1. And negative 2, 2, 2. Actually, yeah. We don't need to, this is always like this. So here, negative 2 comma 4, 4, 2. So here 2 comma 2 becomes like this. So 2 comma 4, 4, 2. So 10. So actually this one is between 1 to 10. So it's 1 to 1 over 10 like this. So this one is 1 over 10. But anyway, whatever it is, it's smaller than or equal to 1. Therefore, f prime of x is smaller than or equal to 1. Let's go to the next one. Number 7. So integral f prime of x, like this. Yep. So integral dx. This we need to separate them. L minus square root of 5x squared dx plus integral 5x over 1 minus 5x squared dx. This is because when we have something on numerator, like on the right side, 5x, then we need to see like 1 minus 5x squared. We need to consider the substitution, integration by substitution. But on the left side, it is only 1, means we cannot use that. So left side is the arc sign, and right side is substitution. So let's say u becomes a square, no, actually we can use reverse chain rule. So here, arc sign square root of 5x over square root of 5. Actually, reverse chain rule is just a substitution. If you don't find that this is easy, then you can use the substitution. So here u becomes 1 minus 5x squared, du becomes negative 10x dx, then dx is negative 10x du. So integral u to the negative 1 over 2 n 5x n du negative 10x. So 1 over square root of 5 arc sine root 5x minus 1 over 2 u to the power of negative 1 over 2 and u to the power of 1 over 2 and 2, so 2 u to the power of 1 over 2 plus c. So 1 over square root of 5 arc sine square root of 5x minus u was this one, square root 1 minus 5x squared plus c. So a is negative 1, b is square root of 5 over 5. And number 8, you can do that. You can use the arctangent horizontal asymptote. And number 9, let's see. So this is again the same thing like just now. I separate them like 1 over and 2x over because they had different approaches. So 1 over is arc sine, arc trigonometry, like inverse trigonometry. So here also 1 over 1 plus 4x squared, maybe you can use arctangent. And 2x over 1 plus 4x squared, you use the substitution. Then you will find it. And number 10, Number 11, oh, this is not the, but I think number 11 looks difficult. So let's try number 11. Always this trigonometric substitution make it difficult. So x becomes sine x. So dx cos x cos theta d theta. So integral when x equals 0, theta becomes 0. X equals 1 over 2, theta becomes pi over 6. So 0 to pi over 6. Sine to the power of x to the power of 4. And what is that? No, sine theta. Now I'm going to sine theta. So sine to the power of 4 root 1 minus sine squared theta, and dx is cos theta d theta. 1 minus sine squared theta is cos squared of theta. So when we apply this square root, then this becomes cos theta. So now we can cancel out. So integral 0 to pi over 6 sine to the power of 4 of theta d theta. So when we have this multiplicity of even number, sine has 4 now, then we need to use the cosine double angle identity. So you need to remember, even this is a sine, we use cosine double angle identity. So here, because we don't know this higher degree of the trigonometric functions. So let's see. Cos 2 theta is 1 minus 2 sine squared of theta. So sine squared of theta is 1 minus cos 2 theta over 2n squared. Means sine to the power of 4 theta is 1 over 4, 1 minus 2 cos 2 theta plus cos squared of 2 theta. Cos 2 theta, cos 4 theta is 2 cos squared of 2 theta minus 1. So my intention is just reducing the degrees. So cos 4 theta. Cos squared of 2 theta is cos 4 theta plus 1 over 2. So this becomes again 1 over 4. 1 minus 2 cos 2 theta plus cos 4 theta plus 1 over 2. So 1 over 4. 3 over 2. So 3 over 8 minus 1 over 2 cos 2 theta plus 1 over 8 cos 4 theta. So this is sine theta of 4. So now we calculate, like we can integrate this one because we can integrate the first degrees of them. Cos 4 theta d theta. So 3 over 8 theta minus 1 over 4 sine 2 theta plus 1 over 32 sine 4 theta 0 to pi over 6. And yep, let's find the final answers since we are here. So here 3 over 8 pi over 6 minus 1 over 4 and sine 3 pi over 3, so square root 3 over 2 plus 1 over 32, so 2 pi over 3, which is the same, 3 square root 3 over 2 minus 0 0 0. So this one pi over 16 minus 8 over square root 3 plus 64 over square root 3. So this is 64 over 8, 64 over 4. Therefore, 64, 4 pi minus 7 square root 3. Yeah. So this is the answers. And let's go further down. Number 12. Yeah, you will find as it is. And number 13. Sorry. I mean, I'm reducing it. Why it doesn't? So number 13. So here, anyway, the denominator is factorized from x squared plus 9 and blah 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 dx. So let's use the partial fraction. So in this case, 2x cubed 2x squared 18x plus 9 over x squared plus 9 and x squared becomes x squared plus ax plus b plus x squared plus 9 cx plus d. So now ax 2x cubed plus 2x squared plus 18x plus 9 becomes ax plus b n x squared plus 9 plus cx cubed plus dx squared. So here 2 becomes 2 plus c, because here 2x cubed, a plus c, sorry, a plus c. So x squared 2 is b, only b. So here b plus d and xd. 18 is here 9a, and we don't have, and 9 becomes 9b, the constant term. So b equals 1, a equals 2, then c equals 0, d equals 1. So now we understand this one, 2x plus 1 over x squared plus c equals 0, d becomes 2 over x squared plus 9. So now we can solve this out. So this one, integral 2x over x squared, which is 2 over x, will be go to ln x, plus 1 over x squared will be the second term, plus 2 over x squared plus 9, which will be arctan of x. So here 2 ln x minus 1 over x plus this one becomes, let's take it out 9. Oh, then 9, 1 plus x over 3 squared of 2. Then 2 over 9 arctan x over 3 times 3 dx plus c. Am I right? X 3 to the power of squared. When I make the form of arctan, then it becomes like this. And because it's the reverse chain rule, I need to multiply 3 because it's the derivative of x over 3. So like this. So A is 2, B is 1, D is 2 over 3. So this is the one. Let's go to the next one. And yeah, this is the same. You will do that. And number 15. Let's do that. So this is same. So here 2 x, because this is x squared plus 1, b x squared plus 1, x plus c, because always just 1 degree less. The standard form is on the numerator. So here a 2 becomes a x squared plus 1 plus x bx plus c. A plus b should be 0 because we don't have any x squared term on the left side. And c is 0 because we don't have x term. And the constant term a should be 2. Therefore, b equals negative 2. Integral 2 over x minus 2x. 2x over x squared plus 1 dx. So the first one is just general term. We know already the antiderivative. And this one is the reverse chain rule again. So x squared plus 1 and 2x. So we know this is ln x squared plus 1 plus c. So now mean value 1 over 2. So 2 minus 1 integral 1 to 2 f of x dx. So now we already know this one. Oh, duplicate. And 1 and 2. So 2 ln 2 minus ln 5 minus 2 ln 1, which is 0, minus ln 2. So 3 ln 2 minus ln 5, ln 8 minus ln 5, so ln 8 over 5. So mean value between 1 to 2 is 2 f of x minus, so find the mean value of this one. So 1 over 2 minus 1 integral 1 to 2, 2 f of x minus 6 over x. This is what we need to find. So we know already the first one. So here 2 integral 1 to 2 f of x dx minus 6 integral 1 to 2 1 over x dx. So this one was ln 8 over 5. So this is 2 ln 8 over 5 minus 6 ln x 1 and 2. So 2 ln 8 over 5 minus 6 ln 2 minus ln 1. So ln 8 squared 25 times 1 over 2 to the power of 6, which is like this. So ln 1 over 25. or negative 2 ln 5.